Hello, this is me putting off a video. I mean, this discussion is about a concept I have about possibly a topic in the future that I want to write a video on. But I want to talk about a statistic for openers called opener efficiency. So, what is it? What is opener efficiency? And what does it attempt to do? So, opener efficiency is simply the total attack of an opener divided by it's multiplied by. It's something, some operation like that. The likelihood of that whole attack appearing. So for example, 2 divided by it's 2 times the likelihood. So it's 2 times 0.5 or 50% equals 1, which would be the opener efficiency of that. So if, for example, an attack is you get a 100 attack from an opener, but it only has a 1% likelihood versus an opener that spits out 2 attack, but only has a half likelihood to happen, then they're both around equal, because one isn't going to do it much, but is going to be used a whole lot more than that one that needs that very, very specific cue. So it's just mainly to measure what each statistic does. Not what each statistic does. What each opener attempts to do. Now, its problems. This is wrong, but this value. But its problems are that if you take, for example, it doesn't account for position. So a position, for example, you got a really good position, it's a 4 wide. OE would show it as 0, but it isn't 0 in a way. I don't know if that's a problem or not, but there are a lot bigger problem. There's a bigger problem. The biggest problem that I addressed immediately was mechanical heart and other mechanical-like setups. So I'll show an example in a minute, but if you see my example, I'll go bag through bag, show you its opener efficiency. But if you take, for example, mechanical heart through this current system, you'll have an ever-growing attack with a never-changing likelihood, total bag likelihood. And so, technically, the OE of mechanical heart is infinite. So, that's an issue. It's not very good in that regard. And you have, for example, I kind of mentioned 4 wide. It would show it as 0. It's a setup opener, and it's not very good. And then you have openers that take a long time to do. For example, in 3 bags, you have 2 openers. One sends 6 damage, let's say, and is 50% likely. And the other sends 6 damage and is 50% likely. They both have similar OEs, but one takes longer. One takes a lot longer to actually perform than the other. So that's an issue too, because speed is important. If somebody can dish out that 6 damage or half of that 6 damage early, then you tank that damage and might get sent a barrage of attacks. So that's an issue. But what does OE over bags per bag, what does it fix? Essentially mechanical heart. It more accurately depicts mechanical heart. If I'm going to say anything like that, it makes anything, instead of being like, you make like a really long opener that's like STPC or something stupid like that, and you have it loop and it does like so much damage and it does infinite damage. It pretty much breaks that down. And also, I guess, makes it easier to digest in a way. You're looking at more of a decibel number. But for like, there's a lot. There's still a lot of more problems. It doesn't evaluate positions. Honestly, I think that's fine and can be subjective. In my opinion, that doesn't need to be fixed. But one thing that I do think is a problem is that the opener that does the fastest is a lot better. Like, if I condition an attack that's like 2 bags faster than you, I'm probably gonna win. You know, even though you deal like way more damage than me, it doesn't matter. I still win. And so I want to incorporate that into this. I'm thinking about like quadratics. You know, quadratics, where like it's like multiplied or like added to a value that's like higher, but then as the opener goes on, it falls off quite quickly. And or like something like that, where like by time it will fall off and pretty much be like, the fact that you're still openering is not very beneficial. It would also help with mechanical heart. Not like, mechanical heart can have a defined value, but it would be more helpful to show that, you know, being an opener made forever isn't the best thing, because what if you get spiked with damage? There's probably some other issues. Please let me know about them. But mainly all I'm saying is that like, it doesn't take into account time. I haven't figured out a good equation to fix this, but OE over B is actually decent. Not closing remarks yet, but we'll look at this example. So if we go back to page 1, this is STPC spin. And over here, or over down here, I have pretty much all the information that you need to know. This is bag 1. This has sent so far to attack and is 75% likely. So the likelihood of it is 75%, meaning that 2 multiplied by 0.75 is 1.5 OE per bag. Then if we go to the next one, you'll see that this climbs because I included back-to-back here. I'm still torn whether or not to include back-to-back, but currently I have it. And this is actually 100% build, so the likelihood actually doesn't change. And this climbs. Then we go into here where we spin this. So we have 12 attack now, 75% likely. But the thing is, let's say we have a perfect example. We're here, 12 attack, 75% likelihood. That would be 9, okay? So you have 9 OE. But if you divide OE by B, which is 3, you would have 3, because 9 is a square and you're dividing it by its square root. So you have 3 OE. That's why it doesn't actually really increase like too crazy. I mean, it still does, but like if you can consistently do like T-spin double after T-spin double, like and the likelihood doesn't change, it won't climb. If the likelihood does change and drops, then it will drop. It can drop, but we're for this example, it's not dropping. And then for just the bottom T-spin, obviously you have to place all the pieces for the bag to actually be accounted for. But here you have a T-spin here, which we're going to say is 17 attack, and we're at 3.1875 OE per bag. And then etc., etc. I'm not accounting for the build on top, because the build on top, honestly, I don't want to calculate what this over here, this section here, the likelihood of that. And I don't have to, because it doesn't matter for this demonstration. But for the T-piece here, that's all we need to worry about. And you get this. Out of all of SDPC, including the back-to-back bonus, and I think the back-to-back bonus is slightly higher for Tetrio, you get a bit more OE per bag. But for the most part, that's how it works. That's why in the earlier bags, it may climb like tremendously, and then it doesn't climb as fast. Maybe you have like a rate of change and somehow put that in. Maybe that's something that we talk about, or maybe we just go with quadratics. But overall, that's all we need to know for now. I've been working on this, not too hard, because I've been working on some other stuff that I don't know if I'm even gonna get 100% of the way through. I hope, fingers crossed, but I want to share this with you because I think it's cool. If you have any thoughts, let me know any way you want, whether it's through like a Discord or it's through comments. Just let me know if you figure something out, or if you have other problems with it. I want to know, because I'm making this. It's important for me to, when I'm making something, to take into account all possible problems and whether or not they're problems or not. For example, position, you can just evaluate with your eyes. Or, like, all positions are subjective, and thus there's not really a good fix. So we just say this is the definitive number minus the actual position that you're left with, you know? So, but yeah, that's it for me. Let me know on anything that, you know, is helpful, have questions with, etc. But for now, that's me signing off.